thanks for joining. Good afternoon and good morning, and welcome to today's webinar, Urbanization and Extreme Weather Effects, How Stormwater Detention, Retention, and Infiltration Can Help. Our two presenters today are Tony Tekly, a licensed professional engineer and the manager of our regional engineers team, and Ramtin Zojaji, our sales representative in Eastern Ontario for Armtec's Drainage Solutions business unit, both of whom I'll introduce with more detail shortly. My name is Janine Yetke, Director of Marketing. My group runs Armtec's Drainage Solutions webinar program, and I'll be your host for today's event. We also have James Carter on the line, who is our technical moderator and who will be running questions and answers at the end of the session. For your information, the majority of Armtec webinars do offer CPD credits for 1 hour informal credits. For more information about CPD credits, email Armtec at webinars@armtec.com. I'd like to start off with a brief introduction to Armtec. We are one of Canada's oldest and largest infrastructure companies, supplying solutions ranging from steel and HDPE-based bridge and culvert materials to precast building systems. With locations across the country, we are well positioned to serve your needs wherever you are. We also have an international sales group to support you with project locations around the world. As you can see, Armtec offers products in a wide range of categories, including precast products such as building systems, parking structures, and sound wall systems. On the drainage side of the business, we offer pipe and culverts, engineered steel bridge solutions, and of course, related to today's presentation, stormwater management systems and much more. We serve numerous sectors from municipal to forestry and mining and energy. More about how we service these sectors can be viewed on our newly revamped website or through discussion with one of our experienced sales representatives. With our centralized engineering department and regional engineers, Armtec has the exceptional capability to fully support design and challenging engineered project requirements. Our company also has the expertise to take your project through all phases of the design and construction process with the design, build, delivery method. Presenting today are two Armtec employees, Tony Tekly and Ramtin Zojaji. Both Tony and Ramtin have a wide range of experience providing recommendations for stormwater treatment and management units, which they will present today. Tony is the manager of the regional engineers team, which spans the country and is based in Quebec. He has over 17 years of experience in the industry and has been actively involved in the specification, design, and construction of numerous projects including stormwater solutions, culverts, bridges and tunnels, just to name a few. Ramtin is a sales representative with Armtec located in Peterborough, Ontario. He consults regularly with engineering consultants, municipalities, and contractors to identify the best solutions for their needs. He has been involved in the installation of stormwater treatment systems, culverts, and multiplate, and supports Armtec's entire portfolio of drainage products. Both of them look forward to plenty of questions and answers after the presentation. And with that, I will now hand off this presentation to Tony Tekly. Welcome, Tony.
Thank you, Janine. Good day, everybody, and welcome again to our webinar. Today, we are going to tackle the different challenges we are facing with the extreme weather conditions and the urbanization effect witnessed across the country. We will start with an overall overview. Then we will list the different Armtec solutions of detention, retention, infiltration, and finally, stormwater treatment. The final part will be handled by my colleague, Ramtin. As you may already know, we are witnessing an increase in the precipitation intensity and number of severe storms. Some regions of Canada, several 100-year storms have been witnessed in the span of decades. Multiple studies have also shown that by 2050, an actual 10-year drainage structure will be able to withstand a 5-year storm. A 50-year drainage structure will only be able to handle a 20-year storm. At the same time, population needs for new land is also increasing. This is resulting in the densification of already saturated urban areas and expansion into new areas, especially in the suburbs. Impervious surfaces are popping everywhere, reducing natural soil surfaces and thus eliminating the rainwater infiltration and natural ground discharge. At Armtec, we have assembled a line of products to tackle these issues. Similar to a good hockey team, we have identified a line of 3 forwards, another line of 2 defensemen, and a goalie. Our 3 forwards are CSP ULTRA-FLO, HDPE, SRPE pipes. Our 2 defensemen are detention retention tanks, infiltration, and our goalie is the stormwater treatment. Our first forward is the Hel-Cor corrugated steel pipe, which is illegally made with a lock seam. We have a wide range of diameters ranging from 150 to 3600 millimeters with different combination of thicknesses, corrugation, coatings. We also have custom lengths of 6 and 9 meters, and we can go up to 15 meters on custom-made lenses. We can also offer different lenses. If you need, for example, the 6.5, 7, or 9, or 8 meters, we can accommodate that. This pipe is certified, is manufactured according to CSA G401. The different corrugations we have with the Hel-Cor pipe, which are the 38 by 6.5, 68 by 13, and 125 by 25, offer the structural ability of the pipe. You can also see at the right corner the detail of the lock seam for the Hel-Cor pipe. We also have the cousin for the Hel-Cor pipe, which is the ULTRA-FLO. The difference between the ULTRA-FLO and the Hel-Cor is the manning coefficient. We have practically a smooth interior for the ULTRA-FLO with a manning of 0.013. It has the same coating. You can offer them with the same coating as the regular Hel-Cor pipe. The structural part of the pipe is handled by a rip of 19 millimeter by 19 millimeter that you can see here, span each 190 millimeters. We have a variety of diameters going up to 2600 and 2 different thicknesses, 2.0 and 2.8 millimeters. We, as seen before, we have 3 different coatings for those 2 types of pipes. We have galvanized steel with an estimated service life between 25 and 50 years. We have the aluminized type 2 steel with can offer a service life up to 75 years, and a polymer-laminated steel which can go up to 100 years and more. Our polymer-laminated is also known commercially as TRENCHCOAT, combines the strength of steel with the durability of plastic. The CSPI, which is the Corrugated Steel Pipe Institute, has issued this small chart which will inform us about the ways to maximize the investment return for each kind of coating. For example, if we take the pH levels that we witness on each side, ideally a galvanized pipe will perform the best between 6 and 10. Aluminized will perform best between 5 and 9. Polymer laminated between 3 and 12. Resistivity-wise, galvanized is good between 2,000 and 8,000. Aluminized 1,500 and more. Not an issue for the polymer. Hardness, any concentration above 75 ppm is good for galvanized. It's not a factor for aluminized. It's not a factor for polymer. The hardness effect is very important for the galvanized steel. We, in some parts of the country, we have installed the galvanized pipes which have more than 75 years of actual service, and they are still in good condition. Enemy number one of galvanized and aluminized steel is the chloride, which is the salt we use on the road. Any concentration above 150 ppm for galvanized or 190 for aluminized is very bad. It's not a factor for polymer laminated. With those two kinds of products, Hel-Cor and ULTRA-FLO, we offer a wide range of fittings. Could be Ys, could be Cs, could be inlet, outlets, we can offer risers, we can offer adapters, any kind of adapter, anything you can imagine, anything you can draw, we're able to manufacture, or all of this is done at our factories located across the country. Those two pipes, we also offer two kinds of couplers. The first one is a soil-tight kind of coupler, which is a standard coupler. And for a watertight application, we use the hover band. Our second forward is the high-density polyethylene corrugated pipe, which is basically made from virgin and recycled resin. We add to it some carbon black, minimum 2% to protect against ultraviolet radiation. The BOSS 2000 range of products is a pipe which is a smooth interior with a corrugated outside wall. Is made to diameters up to 900 millimeters. With a standard length of 6 meters. We also offer different custom lengths that can go up to 15 meters. We offer two range of stiffnesses, which basically gives the structural integrity of the pipe. We have 210 and 320 kPa. We offer them both in solid or perforated. For the perforated one, we can offer an additional filter or geotech style, any kind of geotech style based on site conditions the pipe can be fitted with. This is a smooth interior pipe, so the manual coefficient is very low, up to 0.012. We have a wide variety of joining system for the BOSS 2000. We have soil-tight, different kind of couplers, and we have watertight ones with bell and gasket. We also offer a MANHOLES coupler for special applications. The second range of HDPE pipe for higher diameters is also similar to the other one, except for the stiffness. The stiffness will vary and will go down with the pipe diameter. So basically, a 1050 will be 179 kPa, and a 1500 will be 95 kPa. It's a standard length of 6.1 and joint is a bell and spigot, the same manning as previously talked about. As with the CSP pipe, we offer a wide range of fittings. They can range from elbows, T's, Y's, reducers, any kind of fitting you can imagine, manhole adapters, couplings, risers, whatever you can think of, we can have it. With the HDPE, we can offer also dual wall manholes and triple wall manholes. The difference between the triple wall manhole is we add a third layer to make it a smooth wall exterior for the manholes. As you can see, we can adapt, we can add multiple inlets, outlets with different diameters to those manholes. Our third forward is the steel reinforced HDPE pipe, commercially known as DUROMAXX. Basically, it's a smooth interior wall HDPE pipe with a steel rib encapsulated inside the polyethylene. This kind of steel reinforcement will enable the DUROMAXX pipe to have bigger diameters, so we can go up to 3,000 millimeters, and it will also increase the strength of the pipe, so it will withstand higher covers and higher live loading. We offer them with typical lengths of 4.3 and 7.3 meter as a standard, and we can go up to a 15 meter long custom ones. We offer different joining systems depending on the site conditions. We can offer soil site, cover joint. We can offer a non-reinforced bell and spigot, which gives us a water tightness up to 3 psi. If you need more water tightness up to 15 psi, we can add a reinforcement to the bell. Additional water tightness up to 35 psi could be achieved with the ELECTROFUSION. This is an example of the reinforced bell. As you can see, there is an encapsulated steel plate inside the bell, which will give it an additional rigidity and increase its water tightness compared to regular non-reinforced HDPE bell. For additional water tightness, this is the detail for the ELECTROFUSION. As you can see, there is an outside metal flat band to help during the installation. All the water tightness is achieved through the ELECTROFUSION from the inside of the pipe made as soon as the pipe has been installed. Our first defenseman is the retention tank. The main difference between detention and retention is that a detention tank will capture water in a tank, in a big tank, and we will be able to discharge this water from an outlet at a rate that is fixed by the engineer or the city authority. The retention tank is the same as a detention tank, but it is perforated with the use of an additional wash stone, could be used outside it. What we will do is we will mimic the actual before development of a land. So basically, the water will go inside and then will go dissipate inside the land and go down as it will be usually doing without the new development. Some design and construction considerations. Usually, hydrology and hydraulics are handled by the consultant. He will get back to us with his storage requirement, and we will ask him about the footprint he has on site. We will handle the structural design. We will propose him a layout, and we'll give him some guidelines on the installation and give him the guidelines on the maintenance, inspection, and cleaning of each detention or retention tank. Basic components of a typical retention or detention tank: we have the branch pipe, which is made by a regular pipe, and we have also the header pipe, which assumes the flow inside those branch pipes. We also have bulkheads. We also have outlets, couplers, crossover to connect the different branches. And we also finally have risers, which will enable us to do maintenance, which will enable us to do any cleaning or inspection. This is some examples of those components. We have here the headers with integrated riser. We have a bulkhead with integrated riser. Crossover, the outlet. The outlet can be put anywhere. We have the possibility also to include inlets or outlets anywhere inside that system. One of the advantages of detention-retention tank is versatility. Depending on the footprint you have on site, we are able to make any kind of layout to fit what you have on site. So this is one example. We can also have different kinds of application. We can integrate elbows inside our detention tanks. As you can see, we still have all the regular components: bulkhead, risers, headers, outlets. This is a different combination also. Here are some examples of CSP ultra-flow detention tank. As you can see, we can offer with CSP a wide range of diameters, small, big ones. You can see here the risers. The number of risers actually depends on we recommend at least one riser per system, but we can make as much as an engineer can want on each system. Some other examples of HDPE detention tanks. Approximately it's the same as regular CSP, but it's HDPE. You can see here a triple wall manhole HDPE, and the connection between that manhole and the different branches. Our last example of detention tank is the SRPE, which is the DUROMAXX. It's not only used, DUROMAXX could not only be used for stormwater, but we can use it also for non-stormwater. For example, we can use it for sanitary sewers or combined sewers. Here at the bottom left side, it's a combined example. It's an example of a combined sewer. You can see the metal band on the outside part of the pipe. After the system has been installed, a team entered and did the electrofusion inside that system. We at Armtec, we offer a design tool. This design tool is very simple. It's actually an Excel sheet where you add the wanted volume you need to detain. You add some basic information about the dimensions or the elevation. You also choose the pipe size, and you choose if you want it as a detention or a retention system. And if it is a retention system, you can add some data about the distance between the pipes and the height of washed stone to use and the porosity of the washed stone. And the Excel sheet will give you back the total volume that the pipe is going to hold, the total volume that the wash stone will hold, a preview of the layout, the quantity of all the branches, all the couplers, headers, risers, total quantities of trucks needed, and also to give you an idea, approximate idea of the total excavation, total wash stone quantities you need for that site. Our second defenseman is the CHAMBERMAXX, which is part of the infiltration system. Basically, CHAMBERMAXX are chambers, plastic chambers with an open bottom infiltration. They are very cost effective for shallow applications. They practically reduce or eliminate site runoff, and at the same time they can recharge the water table. Basic components of CHAMBERMAXX, we have a start chamber, a middle chamber, and an end chamber. Also, we have an inspection port. We also have a scour netting and a header type or manifold. We recommend also to have a pre-treatment system before the CHAMBERMAXX. This is a 3D view of the same components. As you can see here, one of the advantages of CHAMBERMAXX is that the end chamber has an integrated end wall. This is the inspection port, this is the header manifold, and this is the pre-treatment system. The CHAMBERMAXX has withstood a full scale of in-ground burial test with height of cover ranging from 450 millimeters to 3,000 millimeters and live loading of HS20, HS25. We recommend to have a minimum spacing of 125 millimeters. Standard dimension of a regular CHAMBERMAXX is a span of 1,300 millimeters and a rise of 770 with an average length of 2,100 millimeters. With that, including the surrounding stone, a CHAMBERMAXX is able to take approximately 1 cubic meter per linear meter of CHAMBERMAXX. This is a detail of the header pipe, usually made of elbows and T's and connected to each other with the Marmac type of couplers. We have a wide variety of diameters available, 300 to 600 millimeters, and usually you would connect it to the CHAMBERMAXX using the guide, the cutting guide, as you can see here on the wall end of the chamber. We also have the inspection port. Inspection port basically is a 100 millimeter PVC pipe with a cast iron ring and cover. Usually recommend to have at least one port per system and one port per containment row. We will also recommend to pre-treat the water before entering the system to help reduce the quantity of sediment and to increase the efficiency of the system and to reduce also the cycle of maintenance needed for the CHAMBERMAXX. Instead of using a pre-treatment system, we can also use a containment row. Basically, the containment row is a regular CHAMBERMAXX row, which we have added a impermeable membrane wrapped all over the chamber. When we want to do a maintenance on a containment row, all the sediments will be trapped inside the chamber, and we have a back kind of washout that's going to bring the sediment from the back end of the unit to the inlet to the manhole at the beginning of the system. Typical installation of CHAMBERMAXX. As you can see, this is a typical section. We have a geotextile wrapped all over the wash stone. The wash stone is below and above the chambers. This is a typical section of a chamber, and we can see here the inspection port. The sequence of installation, we start by excavating until the required elevation. Then we prepare the subsurface. We lay over the first layer of geotextile between the existing soil and before adding the washed stone on it, the first layer of washed stone underneath the CHAMBERMAXX. We install the scour protection netting and the header pipe. Then we connect them to the chambers and install the remaining chambers. As soon as we finish, we backfill with the washed stone to the required level. We place the geotextile to protect the washed stone, and then we place the remaining backfill as requested until the pavement level. Manufacturing-wise, it's a very simple process. The CHAMBERMAXX is an injection molded polypropylene product with superior resin structurally and a superior quality. One of the advantages of it is the integrated end walls that will prevent the loss of soil from the top if the non-integrated wall will break down from the regular from the end unit. As per the retention system, we have a design tool which is available as an Excel sheet. It's also very similar to the retention system. Basically, you input the required volume, the depth of the invert, the limiting width. If you want to use the porous stone, what are the thicknesses or the depths of each below and above the system, and the density or porosity of the stone. And the system will automatically generate a preview of the layout. It will also give you the number of chambers, the total volume. It will give you the volume from the chambers itself and the volume from the porous stone. It will give you an idea also of an approximate rectangular footprint, and we will also have a detail of the number of middle units, start units, end units, the manifold, the header unit. We will also give you a quantity of the scour netting, the geotextile used, the number of trucks needed, and as well as the total excavation volume, stone backfill volume, and the remaining backfill to grade. Now I will move over and transfer the presentation to my colleague Ramtin for the stormwater treatment part. Thank you.
Thank you very much, Tony. My name is Ramtin, everyone. Hello, everyone. Today I'm going to talk about our stormwater treatment unit, VORTECHS, which is Armtec's flagship of stormwater treatment offering. It's a shallow profile, high flow, hydrodynamic separator. But before I start my presentation, I would like to start by reviewing the reasoning behind the soaring demand for the underground water treatment and management and the urgency for such solutions within municipal and private projects. As Tony mentioned in the beginning of his presentation, and I believe this slide is very self-explanatory, by more and more developments that we create, we destroy soft services, and we only add to the hard ones. As you can see on the left side on the slide, forests, meadows, farmlands, they absorb rain and storm water and gradually release it to the aquifer, but they not only absorb water. During this process, not only do they prevent the water from flooding, but they filter the water that goes to the aquifer. So it is obvious that the speed of the development is just increasing and increasing, and our infrastructure are far behind. And this caused the major issue, which is the increase in runoff. There are two main negative effects. There are two sides of two negative effects, qualitative and quantitative. From the quantitative point of view, increase in the amount of the water flowing to the closest river, adjacent lake, or in many cases overflow the municipalities' storm and sewer systems, and all these cause the flash floods that we witness all these days. And from the qualitative point of view, the negative problem obviously is the pollutants. The pollutants that enter the waterways. Untreated stormwater contains chemicals, heavy irons, and many other harmful particles. So, as I mentioned in the beginning, VORTECHS is the Armtec's flagship of stormwater treatment offerings. It's a shallow profile, high flow hydrodynamic separator. It's comprised of a rectangular valve with an inlet on one side and outlet on the extreme end. A swirl chamber and two baffle valves. The first part is the swirl chamber, which is made of marine-grade aluminum. And this means that the chamber is highly resistant to the salt water, which increases the longevity of the product significantly. The other parts are a floatable chamber and floatable baffle valve, and downstream to these is the second baffle valve, where it houses two devices, low and high flow controls. As I mentioned, the VORTECHS is a shallow profile, which is a very unique feature of this product. And this lends it lots of advantages versus other competitive hydrodynamic separators. The maximum height is only 7 feet, just over 2 meters. And the height from the base of the structure to the invert of the inlet pipe is only 4 feet. So VORTECHS is able to collect pretty much all the pollutants that we are concerned about. As shown on the pictures on the slide, it can collect trash and debris, as you can see on the lower left-hand corner picture, and oils and hydrocarbons showing on the upper right-hand corner, and sediments, coarse and fine sand. And as you can see on the picture, the water is very murky and dark. So apparently, the system is not doing a great job because the sand is present in the stream, and that's why it's not a clean water. So how does it work? So I'm going to talk about the mode of operation here, and I'm going to show an animation and at the end of my presentation. So when the stormwater in the gets into the soil chamber, the sediments, coarse and fine sand will be collected at the bottom of the chamber. After that, water will enter the floatable chamber and will face the first baffle wall, which is called where floatable oil and grease are trapped at the surface water against the wall. And these, along the sediments collected in the soil chamber, can be cleaned and collected at a later time. In the next stage, water will face the second baffle wall with two flow controls, as mentioned before. The low flow control regulates flows within the valve during the low intensity storm, and high flow control has been designed for the same functionality only for medium and high density storm events. One unique feature is that the low flow control device functions by backing up water at the beginning of a storm event, and this instantly submerges the inlet pipe and increase the laminar condition within the soil chamber and allows the particles to settle out of the solution. And another unique feature for Vortex is having 3 manholes access, actually. This allows for subjective inspection of the unit. With Vortex, we can have maximum 2 inlets, but we can have as much as outlets that required, as long as the wall can accommodate. The benefits of Vortex, first of all, it can achieve 80% removal efficiency of 50 micron total suspended solid, TSS, particle size. And I think it's very important to mention here if we are working on a project. So we have to consider the particle size in order to be able to compare apples to apples. Because I have seen, from experience, I have seen in many cases that they mention 80%, but the particle size are not, or they have not been mentioned. So this should be considered very carefully. The other one is online and offline configuration, and this can be precast. I mean, the Vortex can be precast or cast in place, and I'm going to talk about it a little bit later. And the shallow profile and unique horizontal design. Most of the other units available in the market, they go up to 20 feet deep. So this creates such a competitive advantage for Vortex to avoid conflicts with bedrock, groundwater, and underground utilities. And also, as I showed, that there are 3 manholes for inspection. So inspection and maintenance can be done unobstructed access and very easily, very easily. Regarding the approvals and acceptance, we have all the major approvals for Vortex. You can see New Jersey Department of Environmental Protection. We have MOECC. As you can see on my slide, it's mentioned 100% approval record. As many of you may know that with MOECC, it's a case-by-case approval. So far we have a record of 100% approval. We have the approval with the Road Authority, City of Toronto, Lake Simcoe Region, and Conservation Authority, Toronto Region, and as well as the Durham Region. As mentioned, the maintenance is very easy, very accessible for Vortex. We recommend maintaining and cleaning the Vortex unit once a year. And the only point I would like to mention here is that for cleaning vortex unit, you only need to open the manhole on top of the soil chamber, because when the vacuum sucks the water and the sediments from the soil chamber, other debris from the floatable chamber will move back into the soil chamber throughout the cutoff wall. So this is a precast unit. We installed this in Ottawa Airport. Actually, this is one of our. This is the biggest unit that we can ship as a precast. It's a 21 feet by 24 feet, and as you can see, it comes in 3 modules for easy installation. For the smaller sizes, we can ship it as a completed product. They installed this at the airport just as an emergency jet fuel spillage. And this is a cast in place done in Toronto. And as you can see on the left picture, they're installing the soil chamber. And on the right, you can see the final unit, finished unit. So I'm going to show an animation here. Showing how it works. This is the dry weather, dry condition. And I'm just going to move to low intensity storm. So as you can see here, the low flow device is just getting submerged and submerge the inlet pipe, the sediments. So it creates a kind of calm situation in the soil chamber to have the highest efficiency for sediments to settle down. So medium intensity storm event, the water increasing, going to the high flow device, and floatable are getting trapped at the baffle wall, floatable baffle wall here, as you can see, and high intensity storm, as you can see, at the maximum capacity of the vortex unit. And this part will show the clean out. As I mentioned, you're going to see that only one manhole needs to be opened, the one on top of the soil chamber, and it cleans the whole unit. So I'm going to pass it off to Janine again to continue with the presentation.
Great. Thank you so much, Tony and Ramtin, for your presentation. And thank you for joining today's presentation. We hope that you enjoyed it and found that it was informative. Our question and answer period is coming up. Please continue to submit your questions. First, I'd like to go over a couple of housekeeping items. Today's presentation was the first of our fall webinar series. We have 2 upcoming webinars remaining in the series. The next is taking place on November 20th and will be the first of a 2-part series on culvert design titled Let It Flow, Culvert Design 101, and will cover basic hydraulics, culvert location, and end treatments. The follow-up webinar takes place on December 11th, titled Keep It Flowing, Culvert Design 201, which will focus on structural design, durability, and installation. You can find all the details and registration links on our website. Please stay connected with us. You can follow us on social media, on Facebook, LinkedIn, and you can view past webinars on YouTube. You can also get all the latest on Armtec by following us on our new website, www.armtec.com. We really do value your feedback. And at the end of the webinar, there will be a quick exit survey. We'd like to know what you think of this event. Question 6 will ask if you're interested in receiving more invitations for Armtec webinar events. Due to strict Canadian anti-spam legislation, we are required to have your consent to receive future invitations for webinar events. If you want to ensure that you are on our invitation mailing list, please choose yes to consent on our exit survey. If you do choose no, you will be permanently removed from all emails and webinar announcements. So please, we hope you choose yes and join us again. Okay, and now we'll be moving into our question and answer session, which will be moderated by James. Thank you again for joining today. We welcome your questions.
First question came up towards the beginning. How does DUROMAXX compare cost-wise to other pipe materials?
Tony here. DUROMAXX is a new technology, and basically with new technology it is more expensive than regular CSP or HDPE pipe. Depending on the location of the project in the west or in the east or even in central Canada, the range of products varies, but you can at least say it's double or more than double the price of regular pipes.
Tony, if I may, I'm going to add something here. As Tony mentioned, this is a newer technology, but for projects with larger diameters, and so we could be more competitive compared to other technology, or if there's a precast pipe involved, so we could be competitive, hopefully. And also, in terms of shipment and logistics, we could create a competitive situation. So case by case, we have to look at it and see if we can be more efficient or not.
Can water have a straight through path on the vortex unit instead of a 90-degree change in direction as shown?
No, there should be. Like I said, they need to be 2 inlet pipes, right? So each pipe, they should be perpendicular to the wall, and if there are 2 pipes, they have to create the revolving motion. So they cannot be, they should be 90 degrees and tangent to the soil chamber.
Are there any typical guidelines for unit cost range for retention and detention storage per cubic meter, supply and install?
Usually it depends on the different combinations we have. What we have seen is that as soon as you increase the diameter of the detention system, the need for excavation, you will have a lower footprint, and the overall price of the system will be lower than smaller with smaller diameter pipes. But really, it's going to be depending on each site, and we don't have actual numbers.
That's great. Thanks, Tony. Can you please explain the online and offline configurations for the stormwater treatment unit?
Sure. There is no internal backup for vortex. So if there is existing, for example, there's an existing subdivision and we install the vortex, we can have a backup line in case of the stormwater event that surpasses the capacity of the vortex. So it means that it can be done offline and online as well. Yep.
Excellent, thank you. Is DUROMAXX CSA and or AASHTO certified?
DUROMAXX is not yet certified, but they comply to those 2 standards.
Okay, thanks very much. There's a good one. Have you looked at absorptive media to mimic natural surface conditions for areas with clay soils in conjunction with the underground storage? Maybe related.
There is a potential for the use of this kind of solution. Actually, right now at Armtec, we do not offer those kind of solutions. So basically what we have right now, probably in the future we'll be offering more solutions, but for the time being we only have those kind of solutions.
Is there any kind of a price differentiation that you could discuss between galvanized, aluminized, and polymer-laminated coatings?
Good question. Usually aluminized, you have a premium of around 10 to 15% on galvanized. Polymer coated, you'll have an additional premium of another 10 to 15 on the aluminized. But this is only for the supply of the pipes. The cost for construction, for excavation, installation, cost of backfill, it is the same. So the overall cost of your project, the increase in that cost is not going to be the 10-15%. It's going to be, depending on the size of the project, probably in around a couple of percent, 3, 4, 5% maximum. So to get this additional service life of double or triple the service life and only pay a premium of 5% on your project is worth it.
Thank you. What is the effect of abrasion on the different coatings?
The abrasion is very bad for galvanized and aluminized, and even in a little bit for trench coat. But in our application, in the detention and retention system we discussed today, it's not really a factor, as water is going inside. The detention and retention system does not have the velocity in order to make that problem. So this is why we did not discuss about it, about abrasion today, because it's not a major factor as we use in a regular culvert where abrasion is a major factor. So basically, we have seen in retention tank application, a galvanized pipe solution having a higher service life than the culvert in the same area.
Is there a maximum flow set for each vortex unit size or minimize suspension of solids? Oh, sorry. Is there a maximum size to minimize suspension of solids?
This is the part that we do. We do all the design for this. So based on the flow and the sediments that they need to be collected, we do the design. And I should have mentioned this actually. We provide all the shop drawings for this product, and the delivery time is about 2 to 4 weeks after the approval of the shop drawings. And again, these are the parameters that we finalize during the design process.
Excellent. Thanks very much for the questions, everyone. Very good questions. You'll get your continuing education credits before the end of the week next week, along with a link to the slides and a video of this presentation, should you wish to share it with colleagues. And again, keep an eye out for emails for upcoming webinars. You can always find out more at armtec.com/events or /webinars. We'll get you to the same place.
Thank you, everyone.